Hey everybody, this is Electronics Bit by Bit, and today we're getting cozy with Boolean Algebra. Boolean Algebra is the art of expressing a logical problem as a Boolean expression that we can then make a circuit out of to represent. So the way that we have addition, subtraction, multiplication, and division in regular algebra, in Boolean algebra we have A and B, which can be expressed in three different ways. And then we have A or B, which can be expressed in one way, and not A, which is expressed in two different ways. Say you're a teenager again, and you want to go hang out with your friends after school. So you go and ask your mom, and she says that you can only go hang out with your friends after school if I'm home and you've walked the dog, or if dad decides to not stay at the office late so that he's home to walk the dog. So then we jot down our variables and then we write down our truth table, which is a table that shows all of the different possible scenarios. And now we can think to ourselves, how do we turn this into a formula? So the first way to do this is called the sums of product method, where we zone in on all of the times our function spits out 1. So all of the times we do get to go out with our friends. And we take each of these and we run them through their own little circuit that's made of A and B and C. So our first inputs we have are A is 0, B is 0, and C is 0, but we need this to spit out 1. So we can run those inputs through not A and not B and not C to get 1. And then we apply that same idea to all the other times where this function is supposed to give us 1. And then we OR these product terms together. And by that, we're basically saying whatever inputs we have, if they run through this function, there's going to be at least one of these terms that they're going to hit and they're going to turn into 1. And we know that 1 or anything is always going to be 1. So it will cover all the cases where this function needs to give us a 1. First, we're going to build the sum of products function, so we're going to need our usual suspects. We'll need a battery pack, an LED, a switch, some resistors, some gates, lots of them in this case, and some bendy wires. So I've already set up my power connections and I've laid everything down. So what you're seeing from left to right is a NOT gate, two AND gates, and then two OR gates. And then what you're seeing is I'm taking the inputs and running them through the NOT gates and then running the outputs from the NOT gates into the inputs of the AND gates. And then I'm taking the output from the AND gate and putting it into the input of the next well of the AND gate, so then I can AND the third term to it, because in our AND gate systems, it only takes two inputs in. So we put two inputs in, we get a um, term that has two of the inputs, and then we AND it with the third term to get the term that has three of the inputs. Then once we have that, we take that and then we take it to the OR gate. And then we repeat this process for all of the 5 terms, and then we OR them all together. And then we connect that to the LED. So the most painful part about this was that I needed a third AND gate, and so I had to make a special trip to the store just to get this $1 AND gate. Um, so I found that to be really funny. Um, but you see me putting it here on the board, and I would say that this circuit was incredibly complicated to build because I kept feeling like I was going to run out of input spots on the breadboard. And I actually did at one point, but then I came up with some kind of way to fix it. And then we have the board, and it works, thankfully. So, what was the cost in effort and money for this function? So, it took me about 45 minutes to build. The total cost, we needed one NOT gate, we needed three AND gates, and we needed two OR gates, each of which is about $1. And so it was about $6, but then I added an extra $100 for it being a massive pain in my butt. But then I took it off because it would not be a fair comparison. So now we do the same thing for the product of sums function. So we have all our power connections and all our gates down. So going left to right, we have a NOT gate, two OR gates, and an AND gate. And our strategy is basically the same, where we're trying to create sum terms using the OR gate that have all three of our inputs. And then once we have that, we take those sum terms and bring them to the AND gate, and then we AND them all together. And then when we have all of them ANDed together, we connect them to the LED. For this one, I didn't really have a concern of running out of input spots, um, which was really nice, and I didn't need any extra gates or anything like that. As you can see, things are running pretty smoothly. And then in the end, it worked. So that was great as well. So what was the total cost and effort that went into this? Well, it only took me 15 minutes to build, and we only needed one NOT gate, two OR gates, and one AND gate. So it was about $4, and it wasn't a huge pain. So what can we take away from this? Well, our most important takeaway is that not all circuits are built equal, even if they equal to the same truth table. Some are just easier and cheaper to build than others, and the task of trying to find the best circuit in any given situation is called gate level minimization, which is something we'll be talking about next week. And we learned how to take logical problems and turn them into Boolean expressions in two different ways, sum of product and product of sum. So I hope you liked the video. If you would like to read the article that comes along with it, it's on my website and the link is in the description. And if you have any questions about the circuit, about Boolean logic, about what color nail polish I'm wearing, feel free to ask me on my website too.